I'm going to tell you today about the revolution of AI. You know, AI has truly become the new normal for software. All software developers are infusing AI capabilities into every application. And very soon, AI will become just like functions and frameworks that we are all familiar with as software developers, and adding it into our software and imagining new capabilities. I want to give you a taste of this with one example. What you see on the screen is an application called Helpicto, developed by a French ISV, a smaller startup called Equidex. It's an application that allows mothers to communicate with autistic children. You know, the standard of communication for mothers and children, especially autistic children who had a lot of difficulty understanding, was to show them pictures, was to show pictures from a picture book. You assemble a conversation out of pictures, and you, at the same time, you speak to the child, and you communicate bimodally in two ways. And this developer asked a question: why does it have to be so hard to do? Why do I have to pick pictures from a picture book? Why couldn't an app on a mobile phone automatically understand what the mother is saying and translate that into pictures, and you could show it in real time, and the application would be mobile? And he created such an app. Let me play a video to just show you what that looks like.
Arthur, c'est un autiste sévère qui n'a pas de langage et qui a 15 ans.
Pour aider les personnes avec autisme à communiquer, il y a des images. Donc ça peut être des photos, des pictogrammes.
Le classeur, le PEC, c'est pas quelque chose d'évident, de facile. On n'a jamais la bonne carte elle est perdue, elle est tombée sous le fauteuil. D'où l'intérêt pour lui de communiquer avec Helpicto.
Le départ d'Helpicto, c'est des discussions que j'ai eues avec Karine, qui avait une idée depuis quelques temps, mais c'est devenu possible depuis quelques mois. Microsoft a développé ce qu'on appelle des cognitive services, mis à disposition dans le cloud, et qui vont permettre d'exploiter des choses qui étaient très difficilement exploitables auparavant. De la reconnaissance d'images, de la reconnaissance vocale et des traducteurs automatiques de langue. Et ça, c'est important parce que c'est nous donner la possibilité à nous, PME, d'accéder à ce qui se fait de mieux en matière d'intelligence artificielle.
Je parle, je donne une information à Arthur et elle est traduite par l'application Helpicto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
Ce qui est intéressant, c'est qu'il y a une interface qui va ensuite transiter dans tous les milieux de vie de la personne. Ça permet de développer de l'autonomie personnelle, de l'autonomie domestique, participer à des tâches. C'est un outil qui est évolutif.
On a eu la chance d'organiser avec Microsoft un Helpfest, une sorte d'hackathon, où pendant 3 jours, on a été immergé dans une salle de réunion où on a fait quasiment 24 heures non-stop de développement. On y est rentré avec une idée, on en est sorti avec une solution. On est une petite société, on a 40 ingénieurs qui travaillent sur plein de domaines divers et variés. Il nous faudrait des années pour pouvoir construire une solution identique. Aujourd'hui, on a besoin d'une architecture qui est la plus petite possible avec le coût le plus bas possible. Donc on s'appuie sur Azure pour ça et faire en sorte que demain, quand on va atteindre des centaines, des milliers d'utilisateurs, j'espère, on puisse juste appuyer sur le bouton et puis augmenter la charge serveur, la ressource disponible d'un claquement de doigts. Plus on utilise Helpicto, mieux ça fonctionne. Le modèle va continuer à apprendre au fur et à mesure pour faire en sorte de l'optimiser et de le spécialiser.
On va pouvoir remettre en place une communication qui est plus spontanée. Donc en termes de qualité de vie, ça c'est absolument énorme. Je crois que ça aide à recréer du lien.
C'est beaucoup plus ludique, plus facile, comprend mieux. Ça paraît pas grand-chose, mais en fait c'est énorme cette différence. C'est vraiment énorme.
Just huge. And that's the power that every software developer has at their fingertips now with cloud-hosted APIs. Because there are APIs now for speech recognition, for translation, for understanding images, for understanding keywords and entities in text automatically. A developer can go to the cloud, call upon those APIs, compose them together into an app, run it on a mobile phone, and have it available globally within a very short time period. That's very powerful. Now, something like this, even a few years ago, would have taken teams of scientists and researchers and very complex software development processes to build. But now it's simple. It's accessible to everyone in this audience. That's a power that the cloud and AI together are bringing. So here is a simplified version of what that Helpicto apps architecture was like. There was data prep. You took images from around the house, in this case, for cup, water, butter, and things like that. So you could actually then compose your conversation with the images that the child was already familiar with. Computer vision understood what's in each of those images. It would give text associated with those. Now, we used another API for understanding key entities in that. Then there is speech recognition. Speech recognition understands what the mother is speaking. Then the key entities are taken, and they are matched up. And that's how the app is driven. So you set it up. You have a build, train, and deploy phase. And then you have intelligent apps on these mobile phones built using Xamarin, which is cross-platform. So you can develop an application once. You can have it run on iOS and Android and Windows. And you have one app that leverages the brain, the power in the cloud to enable this to happen. There are many more apps like this. If you go to your iOS app store, you will see an app for the blind called Seeing AI that allows a blind person to navigate his environment entirely with this camera. You can interpret what the camera sees. It can actually tell you what your environment is like. You can even understand products. It's actually very, very popular, very powerful. So the AI services in Microsoft's cloud called Azure, they allow developers to build these and even more powerful applications. It comes in sort of 3 groups of services. There is a group of pre-built AI APIs, cloud-hosted APIs. These are called Azure Cognitive Services. There are approximately 35 APIs now and ever growing. These are APIs you can call very, very simply, like it's for speech recognition or language translation or computer vision, and you can integrate that in your apps. Many of them can even be customized with your own data and in that particular limited domain. In fact, for example, there are people who build custom translators of their own for the language of their choice and the specific domain that they want a translation for. Then a second group of applications are conversational AI, of APIs. This is Azure Bot Service and related capabilities to build chat applications, software that allows you to talk to it, converse with it. And that is actually a new trend in user interfaces. It's very, very powerful. So Azure Bot Service allows you to host those chat bots and add a bot brain that allows you to have complex conversations. And then the third group is aimed at the sophisticated machine learning developer. This is custom AI on your own data. It is machine learning on data sources that you bring. You cook the data, you integrate the data, you apply any of a number of open source frameworks like TensorFlow or Caffe or Microsoft's Cognitive Toolkit, build machine learning models with it. And then you deploy that as microservices in the cloud and integrate those microservices into your applications. So let me tell you more about these. So today I'm going to cover 3 major ways how developers use AI in Azure. First, they build modern applications with AI, just like you saw Helpicto. These are applications that understand and interpret the meaning of data, including text, voice, and images. A big part of that ability comes from Azure Cognitive Services. The second is to build conversational applications that allows you to engage with users in very, very natural ways. Azure Bot Services is the backbone of that. The third is to optimize business processes of all types in your organization with AI. These are applications that reason, learn, and form conclusions from data. And typically, Azure machine learning is a big core component of building those. Let's see more about these. So let me talk first about pre-built AI. I believe the vast majority of AI in the future will be leveraged through very sophisticated pre-built APIs in the cloud. APIs that have been built not just with algorithms, but with data they've been built. For example, a speech recognition API uses very large number of tens of thousands, even hundreds of thousands of speech data to learn from. And there are sophisticated language models that have been built of all the language data that you have. And all of these are integrated with acoustic modeling and sophisticated speech processing capabilities, and it all comes packaged together as an API that's ready for you to use. And you're going to see many, many more of those kind of capabilities being built and offered as APIs in the cloud. I can even imagine a future where there are 1 million AI APIs, just like there are apps in an app store. There will be a very large number of APIs hosted in the cloud that all developers can compose into powerful applications. So today, on Azure, we have APIs for vision, for speech, for language, for conversation, for Bing search. By the way, Azure is the only cloud that provides you the entire power of an internet search engine called Bing through APIs. No other large search provider opens its APIs up. And this includes not just internet search, but even image search and a number of other capabilities that comes along with it. And so these are powerful pre-built models, REST APIs, easily customizable, trained in the cloud, and many of these APIs allow you to export models and deploy it anywhere. Very, very powerful. And over 1 million developers today are building applications with these, with Azure Cognitive Services. And here are some of the new announcements that we made. These are increasing the power of the AI that's hosted in the cloud available to every single developer. For example, one, we have now object detection and recognition for thousands of objects in images. It can detect what the object is. It can detect also where in an image a particular object is. Another one, video indexer. Very powerful capability for you to feed in video, and it'll automatically segment it. It'll automatically transcribe the speech. It'll index it so you can search the video by content. You know where a particular piece of content you're interested in is. A third one, speech recognition with customization. Wouldn't you want your speech APIs to recognize your voice very accurately, your vocabulary? Also, even the acoustic model of a stage like this is very different from the acoustic model of a car or a room. Speech recognition APIs today allow you to customize for that. Speech synthesis with customizable voice. This is very interesting. I can train a speech synthesizer, text-to-speech, on my own voice and have it speak like me. God forbid. So it has a neural model behind it that generates a speech of that type. There's then speech-to-speech translation. I can speak in one language and can hear it in a different language. There's text analytics with entity detection. Analytics that allow you to detect key entities like names and places and people. There's language understanding that is integrated into the chatbot, chat service. There's a unique service called Q&A Maker that allows you to take an FAQ and put that into a bot. And if you ask that question that is represented in the FAQ, and you can ask it in a variety of ways, it'll still match it and give you the right answer, the matching answer. It's very, very simple to set up. Again, another API, examples of these intelligent APIs that come online for you to integrate into the app. Bing Visual Search with smart identification, where you can upload an image, and it will search with the image. And in fact, you can take a portion of the image and say, find other images in the internet that look like this, and it will go search for that. Then there's Bing Search SDK is now generally available. It's a very rich wealth of capabilities that can be integrated into any software application. Very powerful, just 10 recent things that we announced. So now let me share with you one other really exciting one. What if you take the power of all of this kind of AI, the AI that can be applied to any type of data, and understand the content of that data, and connect that with a very powerful search capability, like Azure Search. So now we just announced Azure Search with Cognitive Services, which allows you to do built-in enrichment of content that goes into a search index using AI models. Imagine PDFs, imagine images, imagine even audio files, being able to crack all of that, understand what's in that, and make it all indexable and searchable. That's what cognitive search gives you. It adds cognitive capabilities, so to speak, to a search engine. That's very powerful. So the best way to show some of that power, both power of cognitive services and Azure Search, is with a demo. And I want to tell you a fun story. So on November 22nd of 1963, John F. Kennedy was assassinated. The President of the United States was assassinated by a lone gunman called Lee Harvey Oswald. Or so the government wants us to believe, right? So this topic was so controversial that the US Congress 25 years ago mandated that all documents associated with JFK files be released into public domain in 2017. And in 2017, a vast amount of information, over 50,000 documents, if I pile it up, it will cover the stage 7 feet high, was released into the public. How would we, if we were developers, research that data and understand what's in it? Wouldn't you be curious about what's in there, all the secrets that are hidden in there? So one developer in my team created a really exciting application. He ingested all of those PDF files. He enriched it with cognitive services. And then he put a search index on top of it to really explore all of that data. And I will show you that. It's my pleasure now to show you the JFK files. So let's see this application. OK, so a very simple web application. I'm going to type Oswald in there. And as I search for Oswald, you'll see it brought up lots of documents right there, some printed, some handwritten. And Oswald, the term, has been highlighted in each of those. At the same time, here on the left, you see a lot of key terms. These terms were not created by any human being. It was automatically identified from the documents. So let's go take a look at this one. It's a completely handwritten document. And we were able to identify terms like Oswald. Very hard to read even for us. But the optical character recognition that we have can even recognize handwriting. So there's handwriting OCR that transcribed that document, and it linked that in. And you can see which portion it's in. So now let's go back. Let's look at this one. This is an image. Nothing in the image says it's Oswald. But we have now an image entity recognition. We have even celebrity recognition. So it says Lee Harvey Oswald posing for the camera. He's not quite posing for the camera, but that's how it identifies it. It does OCR on the text on his chest, recognizes the numbers, and in fact, as I move my hand over it, you will see it is highlighting that. That's the power of AI to understand what's in an image. Now, I can go here and go click on this and look at all these relationships, who all Oswald is related to, and people like Sylvia Duran, who happen to be a go-between between Oswald and the KGB. There are even very interesting things. You will see, for example, Cuba here. So you could ask the question, why is Cuba there? And I could say, for example, type Castro conspiracy here. And let me see what you find. And what's amazing is you'll see this relationship. There is Castro, and there is something about pills. So let me go look at some of these. So these are documents related to a conspiracy. It turns out CIA had actually worked with the mafia to poison Castro with poison pills. And it was called something called Operation Mongoose. And you discover this all by searching and exploring this. By the way, we didn't set any of this up. we just took the data and enriched with cognitive services, just created a search index, created this wonderful app on top of it. And you're able to now see all the relationships and find things that were hidden in it. And when the government releases a secret tranche of documents, formally secret tranche of documents like this, you hope your name is not in there, right? Now, my name is not in there, but the name of one of Microsoft's products is in there, we found. So there is SQL Server, and it turns out we find SQL Server in the JFK files. Now, SQL Server didn't kill JFK, but it turns out when Congress mandated that JFK files be stored and released, they chose SQL Server as the platform for the working documents. And they had created a secure classified information facility. SQL Server was the platform for working documents. Lotus Notes is the communication medium of the agency. And they even gave us a wonderful architecture, complete with telephone lines and dial-up modems of how that secure classified information facility was built. Exciting. So now let's go back and see what the architecture of this was. So I took the liberty of showing the architecture of this using that clipart format that CIA had conveniently drawn. The data is brought into Azure Storage. So then content from the PDF documents are extracted using a PDF cracker. You're then applying these cognitive skills: optical character recognition, handwriting, computer vision, entity extraction. And then you use Azure functions to even call into custom AI. Now, one thing I didn't show there, I had actually even put in a custom machine learning model to understand which documents had redactions and blackouts versus others. And I can call those kinds of things from an Azure function. So I can hook that new skill as well. And then I put all of that into a search index, and then you put a website on top of it, you can explore very happily. That's the architecture of this. And it's, again, with a little bit of guidance, all of you can explore this. In fact, on GitHub, we have put the source code for all of this out there for you to actually adapt. So here are examples. Thank you. So these are all the built-in skills that went into that app, by the way. It's a very rich collection. There's natural language processing, and there itself you'll see a lot of them. There's image processing, and there's all kinds of utilities. So the ability to bring all of them together in a cloud-hosted app like this, that's very, very powerful. Imagine all the applications of this, whether it be in analyzing legal contracts, or understanding engineering plans, or extracting form information. Our world is surrounded by unstructured data. AI makes all of that unstructured data understandable, organizable, explorable, and analyzable. That deep insight that you get into every type of data that's around us, human-generated data, that's one of the biggest contributions that AI actually brings. So this is where you can explore. You can go to Azure Search portal, start creating that. You can go to that website, aka.ms/JFK files. You can find the JFK files code. It's all out there for you. And that URL is jfkfiles2.azurewebsites.net. So now let me talk about a few more. Conversational AI. Conversations is the new UI, is a new app on the mobile phone. And they're so much easier to use than other applications. Remember, the vast majority of people in the world still don't know how to type. They can't use a computer very effectively. What if you could speak to it? Voice-activated applications are going to be very, very powerful in the future. So Azure Bot Service is meant to make the developer's task of building and hosting these chat applications very easy. It essentially has three major components it supports. So let me show with an architecture. On the left is the REST endpoint. It supports many, many channels. You have Skype channels, Cortana, Facebook, OneNote, SMS, web chat. All those channels are supported for an interactive conversation. In the middle, there is your conversational and business logic, all sort of easy to set up with Bot Framework. Bot Framework provides the tools to set these chat services up. The bot service allows you to host all of this. And then from the bot service, you can call into cognitive services for all the intelligence, for your bot brain, so to speak, whether it be for speech recognition or translation or language understanding and intent extraction. All of those are capabilities that are there. And those are the development tools. You integrate all of this, and then you get a bot. Again, the best way to see the power of a bot like this is with an example from a customer in this case. Telefonica is one of Europe's largest telecommunications providers. They have a bot called Aura, and that is a bot that's very intelligent, built on top of all these capabilities and something you can talk with. Let me play a video to explain.
Okay, Aura. Our conversational AI, Aura, lets us put people first.
We are using artificial intelligence to change the way we are relating to customers. One of the reasons we began to use Microsoft technologies was because it offered an open framework.
It was very easy for all my development team to understand the tools.
We can, very fast and very easy, move into the use cases we want to develop for our customers.
Using tools like Azure Bot Service and Luis, we keep getting new insights and we are applying them into our core business. Microsoft AI was a key piece in our strategy because they have the tools, the platform, the full ecosystem that we needed.
Great. Over 300,000 developers are now using Azure Bot Service, and there are 3,200 bots being created per week. So now let me talk about the third piece, custom AI with Azure Machine Learning, where you are building your own custom AI models from raw data. Look, we allow you to bring your own AI models here for transforming data into intelligence. You can prepare data very easily in Azure. You can build and train machine learning models with any of the open source toolkits. We are in many ways bringing the best of AI, open source and our own, into the cloud for you to help build those models. And then you can deploy those models as microservices using Kubernetes, or take those models out and deploy them even on the edge. That's one unique thing that Microsoft lets you do. While many other cloud providers may want to tie you into the cloud, we allow you to take those models out and run it anywhere you like. So let me explain some of the capabilities underneath. For preparing data, we have an incredibly powerful Spark-based service called Azure Databricks. It's Azure Spark-based analytics, incredible scale. You can distribute computation. You can quickly launch and scale the Spark jobs on demand. It has got a rich interactive workspace and seamless integration with all the data services, so you can pull data from a SQL data warehouse or storage or connect to any of the data sources you want to and bring data in and transform all of that data with the enormous computing power available on Azure. So that's for preparing data at scale. And you can prepare data at the terabyte scale very easily. And then to build machine learning models and train, and to make all of that easy, you have Azure Machine Learning. It has broad frameworks and tool support. See, we are bringing the best of open source into the cloud, as opposed to limiting you to a few things that a particular cloud may support. So you can use TensorFlow. You can use Microsoft's Cognitive Toolkit. You can do Caffe or Keras. You can scale their training from 1 to 100,000 of servers. There's even a Python SDK that's offered, so you can do development entirely in code. And you can run those development scripts in Azure Databricks in a Spark-based environment or on just regular virtual machines. And then there are packages, like Python packages, Azure ML packages for computer vision, for text analytics, for forecasting, that give you higher order APIs that make all this development much, much easier to do. Right? That's the build and train phase. And then when you want to deploy these APIs, Azure Machine Learning allows you to containerize it. With one command, you can build a Docker image, and then the Docker image can be deployed to a Kubernetes service for scale-out REST APIs, or to Azure Batch to run it in batch jobs, or to an IoT edge so you can push it out into the Internet of Things, the edge, and run it over there locally, but still connected to the cloud for telemetry and managing and management of the models and monitoring. And in fact, you can even take those Docker containers, take it to any other container host. You can run it locally on your laptop or on your local servers. All of those features are there. This is end-to-end. Prepare data, build and train using the power of the cloud, take the models, make them web services that are hosted in the cloud or hosted locally. Very powerful. And so this is that entire flow. Prepare the data, build and train, deploy. So here's a customer that's using that. One of the powerful applications of AI is in areas like predictive maintenance and quality control. And Jabil is one of the world's largest manufacturers, in fact, of printed circuit boards. So their factories process vast numbers of printed circuit boards. Turns out they have an optical inspection system to identify when a part might be missing, something is mis-soldered, or there's a quality control problem. However, lots of manual work in inspecting for quality. Lots of false positives in the circuit boards identified as defective. In fact, most of them are OK. A lot of them are sidelined, unfortunately. So we worked with them. We took the images from their factory of these circuit boards and built a deep learning model to classify these images as good images and bad images. And then we deployed it in the cloud as a web service. And now from their automated optical inspection system, images come, are scored by the service, and the service tells the probability that a particular image has a missing component or is defective. So they can do very accurate triage of those circuit boards. Let me play a video to explain that.
People tend to think of Jabil as a contract manufacturer. We are more than that. We're a manufacturing solutions provider. It's a very difficult business. We help customers with taking a product and building it at scale.
We went to the production site and found out the test machines suffers very high false call, around 30%.
Operators have approximately 2 seconds to analyze each one of these images. For some of the boards, they can have upwards of several thousand components on it.
Human gets tired, constantly staring at the same stuff. We thought that was a very good opportunity for us to use deep learning to classify images. The model is actually reducing the workload for operator. For model training, we're using Azure Linux GPU VM, and we're using Azure Machine Learning Services to deploy the model as Docker container. Our pilot is predicting 75% of the past images and can correctly predict 92% of the defects.
It's one of the most advanced predictive projects that we've had going on so far.
So in the near future, the vast majority of quality control, inspection, and all of these types of predictive maintenance applications will be powered by AI. In fact, we have partners, startups, for example, like eSmart Systems, a company in Norway, that builds connected drones to go inspect power lines. Vast amounts of power lines that need to be inspected for flaws, and the drone that flies over has AI that automatically spots defective parts and flags them, and inspection is much easier. So to help developers do all of this work, we have tools like Visual Studio Tools for AI. This allows a very familiar integrated development environment that's integrated with Azure Machine Learning, allows you to leverage the entire power of cloud to really scale out your computation, test your machine learning development, and deploy all of these models. And one thing that, if you are a .NET developer, how many of you here use .NET? Just a pretty good list of people. You're going to find that there's now a great new framework called ML.NET, which brings machine learning to the .NET developer. It's completely open source, by the way. It's cross-platform open source machine learning framework for .NET, built out of internal algorithms that Microsoft has been now using for a decade in all of its first-tier applications, like Bing and others. And it's very extensible framework. You can go to that GitHub site, github.com/machine learning. You can use it. You can participate in the open source development. So here are examples of all the applications that ML.NET is used in. For example, in Excel, when you have the recommended charts, behind that is a machine learning model that creates the recommendations built using ML.NET. In PowerPoint, where design ideas are being created. In Windows 10, where security flaws are being automatically identified and protection is done. In Bing. In many of these places, ML.NET is behind the scenes, and machine learning models created with ML.NET are helping you there. So it's a very powerful toolkit for you to engage with. And then I mentioned about Azure machine learning packages that make development easy. These are also something that we just announced at the Build conference recently, with packages for vision, forecasting, and text analytics, and creating very simple workflows for building and deploying these models and creating microservices out of them. Again, I'd like to show you a customer story. So in this case, it is maintenance of automated parking systems. And they build computer vision models for these. They use these Python packages in Azure Machine Learning to help them build these things very easily. So let me play a video. Now, the innovations in AI are not only in software and algorithms. They're also in hardware. There's an incredible opportunity to create custom hardware that executes machine learning models much faster at a price performance and order of magnitude better than what you can do in CPUs and GPUs, in general purpose computing. And at Microsoft, we have a project called Project Brainwave that designs custom architectures for neural networks. And they can then be executed on an FPGA. FPGA is field programmable gate arrays. And you can configure logic on FPGAs that execute neural networks extremely efficiently. And we announced again earlier, a couple of weeks ago, the integration of Azure Machine Learning and Project Brainwave. And the first instantiation of it was a neural network called ResNet 50, which is one of the best performing for computer vision classification. Now that is burnt into an FPGA. It's available for use with Azure ML. It's very simple to call. It's just a standard API to call. You can even train it to your own data and your scenarios so that these neural networks can execute extremely fast. In fact, we have a record speed of less than 1.8 milliseconds to execute this sophisticated neural network on that FPGA. And the price performance is an order of magnitude better. And it's really the lowest cost, 21 cents per million images scored. You won't ever get that on a GPU or on a CPU, especially if you're scoring one image at a time for real-time AI. And there'll be many more accelerated models that we are going to release. In essence, there'll be a library of these hardware-accelerated APIs that are available to you. And one of the things we did was show a demonstration of this. We took Jabil's use case, where they had these images coming from automated optical inspection systems, lots of images coming. Now, if you don't have efficient hardware for it, it can be very slow. In fact, if you infer a ResNet 50 on a CPU, it can take a second. And then it also is expensive because of the price performance, especially if it is one image at a time. So we set up the system. Images come from Jabil's automated optical inspection system. We built these machine learning models. We deployed it using the FPGA, and it performs dramatically faster. In fact, we were even able to scale this up. At one point, we had run an FPGA-based scoring system using 800 FPGAs in parallel. And in that particular case, we were using satellite imagery. And we were able to score the entire North American continent satellite imagery in 10 minutes, about 20 terabytes of data in 10 minutes using FPGAs at an incredible price performance. Let's see what Jabil has to say about FPGAs and their excitement.
We've been talking with Microsoft about Project Brainwave.
The early test result from Microsoft has shown FPGAs capable of predicting 550 images a second, comparing with a CPU cluster with 40 images a second.
The potential for Project Brainwave is substantial in allowing us to move forward at scale for machine learning across Jabil. Very exciting.
Okay. You can learn a lot more about it at that URL, aka.ms/AML real-time AI. And what you will see in the future is the cloud is going to host real-time AI capabilities at a scale you've never seen before. So a lot of scenarios where AI might have been hard to use in the past become feasible, dramatically faster, and you will see applications just using it constantly. So today, we covered quite a bit. And what I wanted to achieve was open your eyes to the extent of scenarios that are being tackled with AI, how AI is really becoming the new normal. So developers build these modern applications with content-based indexing, search, and analysis, like what you saw with JFK Files. They build conversational applications that engage with users in natural ways through chat, speech, voice, translation. And then they optimize business processes, like you saw in quality control, or fraud prevention, or optimization of a supply chain. You build custom AI models for those scenarios, and they become your company's differentiation. The models that you build with your data become what sets your company apart from everybody else. And using capabilities like real-time AI with FPGAs and edge support, you can now change the game completely in terms of latency and others. And especially the deployment of capabilities at the edge make a huge difference. So, one of the things I wanted to make an analogy to, early in the 20th century, when electricity was becoming common, people were thinking about replacing steam engines in factories with electric motors, right? The factories of the past had these huge boilers and one very, very large steam engine, and then there was these crankshafts and gears that supplied power to every part of the factory, and there were so many machines that were coupled, and that's how these factories used to operate. And when they first looked at replacing the steam engine with electric motors, they looked at the cost-benefit analysis, and they thought, oh, OK, if I replace this one big steam engine with one big motor, how would that be? And most people found, it didn't help that much. I mean, their initial reaction was, it provides only a little bit of increased efficiency, so why use electricity? What they discovered later was that with electricity, you didn't need one single motor and all these crankshafts. Instead, you could have machines all over the factory floor, and each one could get its own electric power, and they would have local motors in each of them. At first, people didn't fully understand the value of that efficiency. But when they deployed it, they found the factory was dramatically more efficient. And then people said, why should each machine have only one motor with a belt and chain? Why not multiple motors? And they created lots of motors in even one machine. And this changed the factory so dramatically that in the first 20, 30 years of the 20th century, there was almost a mass extinction of existing factories. They all got replaced with electricity and local electric power in every one of those factories. Something very similar is happening with AI. You won't see AI necessarily obviously in your face changing one single thing. Instead, AI is going to be infused into every experience. It is going to be local. It's like those small numbers of electric motors that were everywhere that changed the experience of the factory and how efficient the factory was. AI will be running everywhere from your watch to the cloud to the biggest machines and to your cars and to your fridge. Everywhere there will be an experience that is transformed with AI, creating a complete change in how software operates. So when you develop your next application, think of developing it on a cloud. Now, obviously, I am partial to Azure, and here is why I believe Azure, Microsoft's cloud, is the best place for a developer to get started. Because it has the broadest set of these pre-built AI capabilities, whether it be for computer vision or for understanding language or translation or speech. That's where you can get the broadest set. It's also customizable. We have incredibly unique customizability that you can train them with your own data. It also has the most advanced conversational AI and the most differentiated support for AI being run at the edge and with unique hardware. And it is also, when as an enterprise you build your AI application, it is the strongest enterprise cloud. It connects to Office, it identity, provides Active Directory support, and it brings an entire set of capabilities with which you can build a mission-critical enterprise-scale application. So become an AI developer now. And you can learn a lot more about it at azure.com/AI and make AI the new normal in your development life. Thank you.